Just to let you know, this first unit, it's basic some math skills you're going to need to get through the rest of physics. There will be a test on this. The test, it's not going to be a full test. To me, a test is something that takes the whole class. It's not going to take the whole class. It's going to take about a half an hour. It's sort of like a quiz, except I'm going to count it as a test. So it's not going to go under your quiz section. I think I already told you that tests are worth 70%, quizzes and homework is worth 30%. It's going to be halfway between a test and a quiz. It's going to be a quest. Yeah. It'll be about 30 marks-ish, and the first few questions are going to be sig-fig math questions, okay? I'll probably also, when I see you on, when do I see you next? Tuesday, I'll give you a quiz on sig-figs as well, so you can expect that. Really quickly, how many sig-figs in the following? 3, 2, 3, 5, 6, 2, 2, 4, 3, 4, 3, 3. How many? 5. And then it said compute the following, use sig figs. So we're going to do the math. 6.3 plus 10.764 plus 4.56. Well, the answer is 21.624, but I think if I write them vertically, I find that I have to round to this decimal place right here. So I think the answer is going to be 21.6. I'll do C because it's also adding and subtracting. Remember the rule for adding and subtracting, same rule. 67.98 plus 8 plus 43.2. 119.18, but if I look at my data, it looks like this 8 right here is only good to no decimal places. So I think I'm going to have to round this off to, am I right, 119? Then we have dividing and multiplying. The rule for dividing and multiplying is the same rule, different rule than for adding and subtracting. So let's do B, 3.72 divided by 2.1. I get 1.7714, oh, wait a minute, 3 sig figs in the first term, 2 sig figs in the second term. I think I have to round this to 1.8. The last one, 56 times 3.21. I get 179.76. I have to round this to 2 sig figs, so I guess I'm going to have to round this to 180. Or you could go 1.8 times 10 to the second, if you do want to do scientific notation. I haven't done a full lesson on scientific notation with you yet. That'll be coming next week sometime. So, whatever. So those of you that handed that in, you got a little sticker. You got 10 out of 10 for doing it because I just gave you the answers. Those of you that didn't have it handed in, a couple of you, make sure you get it in sometime today. And let's continue with Lesson 3. So let's continue. I've called this Lesson 3 Graphing Review. For most of you, this will be review. For some of you, this may be brand new, or if you've been in a different math stream, or if you're in grade 12 and you haven't done this for a while, it may be, oh, I saw this once, but I've forgotten. So here we go. It says, recall, in Math 10, we learned that equations of the form y equals mx plus b, also called slope-intercept form. Do you remember we defined the slope as, how did we define the slope last year? We used 2 words. It was something over something. Okay. So we told you that the slope was the rise over the run. If you play with the rulers, I'm going to make you wear eye protection. I will. They're rulers, not helicopters, not swords. Put it down, Enzo. The other way you'll sometimes see that written is like this. Change in y over change in x, or delta y over delta x. Or you also got a slope formula last year. If you have the line in front of you, you go rise over run. If you have the points, you went y2 minus y1 over x2 minus x1. the second y minus the first y coordinate divided by the second x coordinate minus the first x coordinate. So a few examples. I wrote graph the following on the grid on the left. Let's look at example 1. Example 1 is in slope. It is in slope-intercept form. How do I know just by glancing at it? Does anybody know how you can tell right away? Yeah.
The y-intercept.
Even more basic than that. The letter y is all by itself. If it's by itself, you're in slope-intercept form. Okay. It says y equals 2/3 x minus 4. Each of those numbers, the 2/3 and the minus 4, tells us something. And if we're graphing this, we actually start out with this number first. What's that negative 4 called? Does anyone remember? Kevin. We called it the y-intercept. The y-intercept of the second equation is positive 5. The last two are a bit weird. We'll talk about that. What did that tell you? Well, the y-intercept meant go on the y-axis, the vertical axis. What did you say the y-intercept was? How big from this equation? It meant go negative 4 down. 1, 2, 3, 4. And put a dot there. What did that number tell us? The 2/3. Slope. Now, I'm going to be fussy. The slope is not 2/3 x, because x is not part of the slope. The slope is 2/3. So this was the slope. How did that apply to the graph? Well, first of all, you learned, hopefully last year, the difference between a positive slope and a negative slope. If the slope was positive, it meant you were going uphill, as you read from left to right. If the slope was negative, it meant you were going downhill, as you read from left to right. So this slope, positive or negative? Positive. What is the slope? Kelly. And what that means is from this y-intercept, count 2 up over 3. And I can remember that it's over 3 because the way you read the fraction out, you actually said 2 over 3. So up 2 over 1, 2, 3, and I put a dot. Up 2 over 1, 2, 3, and I put a dot. Up 2 over 3, and I put a dot. And then I can back count as well. Down 2, back 3. Down 2, back 3. Down 2, back 3. And then I take out my ruler and I connect the lines in a nice straight line. And since we're going to graph more than one line on this particular diagram, I'll even label that with a little number 1. Coming back to you, vaguely remembering some of this stuff? Second one. Enzo, what's the y-intercept of graph number 2?
Positive 5.
Okay, so that means on the y-axis, go 1, 2, 3, 4, 5 up, and put a dot there. Enzo, what's the slope of graph number 2?
-2.
Over what?
Over 1.
Okay, we'll never write the over 1, but we'll remember that it's there. What's the negative tell you? Don't count upwards. Which way are you going to count?
Backward.
Don't count upwards. Which way are you going to count?
Downward.
Thank you for figuring. Downwards and still over 1. It's going to be down 2, over 1. Down 2, over 1. Down 2, over 1. Keep the pattern going. And connect the dots. I'll call that graph number 2. We'll come back to graph 3 in a second. Let's do graph 4 first. What's the y-intercept of graph 4? What number is being added there, Doug? 0. Oh, okay, so that's going to be a graph that goes through 0, 0, the fancy word origin. You know what? I'll use green for that. What's the slope of graph number 4, Doug? Which means count how? Down 1 over 2. Down 1 over 2.
Mr. Dewick, this is like those connecting the dots that we used to do in elementary school.
Yeah. Will this make a picture? Well, it can, but not today. Come on. Yoink. About like that. Oh, I'll call that graph number 4. Let's go back and look at graph 3. What's weird about graph 3 compared to the other equations?
Doesn't have a slope.
Doesn't have no x, first of all, which actually means it does have a slope. What number in front of an x would make the x vanish? Yeah, it does have a slope. You know what the slope is? 0. What was a slope of 0?
Straight line.
All lines are straight. That's why we call them lines. Thank you, Captain Obvious. Horizontal. Horizontal line, right? Oh, what's the y-intercept? Because that is there.
Negative.
This is a line, -8, dunk. And it's going to be a horizontal line with a slope of 0. Okay. Continue. Take a look at the front of the first sheet. This is the one that says at the very, very top of it, finding slopes practice. What do you call a duck that steals? Okay. One of the things you're going to be expected to be able to do this year is to find the slope of a graph, either from an actual graph, like the first 6 questions, or maybe, Stefan, like points from a graph, like the next 12 questions. How do I find the slope when it's a graph? Well, let's do one of these. How about let's do the second one, graph number 2. We'll do that one together. First of all, just by glancing at it, can you tell me, is the slope going to be positive or negative?
Negative.
Negative. Let's write a little negative. I'll put the slope right above here. Negative. And then we defined slope, Janaya, as rise over run, which means negative. I got the down part. I'm going to count the rise, which is the vertical. 1, 2, 3, 4, 5, 6 over. And I'm going to count the run, which is the horizontal. 1, 2, 3 over or under. But then I'm going to reduce it to lowest terms. What is -6 over 3 in lowest terms? -2, I'm going to remember that the over 1 is there. I'm lazy. I probably will almost never write it, but I know it's there. For this particular sheet, once you find an answer, if you go down here and you find that slope, which was -2 right here, if you cross out the square that has the -2 in it, which is the CH square, at the very, very end, whatever squares are not crossed out will tell you, what do you call a duck that steals? Which I know you're dying to know. I don't know. Perhaps.
I got it.
Foiled
You're still going to have to do the math. I do like these end zones, not just because the humor is lame and suits my humor. It's a nice way for me to give you the answers without actually giving you the answers. If you get something that makes sense, you know you've done it right. If you get you've probably zigged somewhere. Let's look at these ones here where they gave you a point. Let's do, how about number 11? Over here in the margin, Kelly, I'd like you to write the slope equation, which was y2 minus y1 over x2 minus x1. Now, if you need to write this out and show your work, great. But if you want to, I give you permission to get your calculator out right now, or your brain. And I actually just go y2, that's the second y value, which is -1, minus y1, which is the first y value, 2. The top of this fraction is going to have a negative 3 on it. Over. And then I repeat the process. x2, which is the second x value, 3, minus x1, which is the first x value, 9. I get negative 3 over negative 6. If you can do that, then Matt, I'm good with it. If you can get the slope showing no work, great. If it was a test, would I show my work? Probably, because I don't want to make a dumb mistake, right? In my homework, do I want to try and get fast and good and almost find this boring? Yeah. If you're constantly getting it wrong, if you are getting on these, then okay, you probably need to write out the slope formula, substitute the numbers in carefully, show your work, and then go. By the way, what's a negative divided by a negative?
Positive.
And what is 3 over 6 in lowest terms? I heard it? 1 over 2. Find the 1/2. Oh, cross out the ig. Okay? So that's how to do that sheet. Turn the page.
Oh,
What did the ape think of the grape's house? I know you're all dying to know.
he thought it was divine.
Really? We're just going to wreck the punchlines for everybody else? You were one of those people who walked into, like, The Empire Strikes Back and just screamed out at the beginning, Darth Vader's Luke's father! And then left, right? Yeah. Uh-huh. Oh, Batman dies at the end of The Dark Knight Rises, if you haven't seen it yet. Or does he? Yeah. Uh-huh. Okay. Rosebud is a wagon, if you watch the famous movie called Citizen Kane. His final words are Rosebud. The movie starts out with that, and the whole movie is to try to explain why on his dying bed this rich man would say the word Rosebud. It's because as he died, he wished he was a child again. And you see the wagon burning on the fire as they're destroying all of his belongings. Anyways, there, spoiled the movie for you. We'll just, you know what? Let's call that cruising a movie. We'll just say that. All right, Doug, my friend. What we're doing here is we want you to find the equation. This is a bit trickier, but this is more often what you'll be doing here in this class. More often, you're going to have some lines, and I'm going to say, tell me the equation. So the first thing it wants us to find is the equation AB. That's between here and here. First thing that I would like to do is I would like to connect them. Yoink. Ruler or freehand. I free-handed it. Doug, can you tell me what the y-intercept of this line is? So, you know what? How about in the margin, I write my template, y equals mx plus b, so I know what the answer is supposed to look like? And Roy, Doug said the y-intercept is negative 3, so my equation is going to look at least like that for now. Oh, and there's going to be an x right there, and in front of it, I'm pretty sure, Roy, it's going to go the slope, yes? Yeah. Okay, you figured out which question we're on now? Yeah, okay. Hey, Roy, the slope of this red line that I drew, first of all, positive or negative? What over what? Count. 1, 2, 3, 4, 5. The rise is 6. 1, 2. The run is 3. Although, would they write 6 over 3? Race, what is that in lowest terms? What? 2. Okay, so for this sheet here, if you find the equation number 1 answer, what did you say it was? 2x minus 3. Okay, it's next to the letters AS, so wherever there's a 1, put an A and an S. Some of these will get trickier to find the equations of, but I think you can handle it. So that's sheet number 2. There's a third sheet. Is there really, Mr. Duke? Yes, there is. Turn the page. Whom should you see at the bank if you need to borrow money? Don't spoil the punchline. Let's just add some extra incentive, shall we? Okay. For this one, now they're going to give you the equation, and you're going to graph the equation. So we're basically doing 3 skills. Finding the slope, finding the equation if you give me a line, finding the line if you give me an equation. Let's do one of these. How about number 5? What's the y first of all, is it in slope-intercept form, Cole? Is the y by itself? Say yes. Very nice. Cole, my friend, what's the y-intercept of graph number 5? So I'm going to put a dot at -1, right there. Cole, what's the slope? Which means count how? More specific, down what over what? Down 3 over 1, and if I go back 1, up 3. If you connect the dots, your line will go through a letter. What letter does mine go through? G. Oh, so where there's a 5 at the bottom of the page, put a G. Does that explain how to do that okay? Okay. I'm going to give you folks about 12 minutes to work on this. Then I'm going to continue the rest of the lesson, and you'll end up at the end of class with about 10 more minutes to work on this. But this is going to be your homework. So a bit of a difference between math and actual science. In math, most of the times when we give you a graph, we're using all 4 quadrants. We're just making up an equation from whatever. Here in physics, in science, almost always all of our numbers are going to be positive. We're almost always going to be in the first quadrant. We're almost always going to be positive x and positive y. And because we're going to be using actual data, we have to be a bit fussier. On your quest that I talked about in a few weeks, one of the things I'm going to do is I'm going to give you some type of data. I'm going to say graph it. Most of you will do the graph part just fine. Many of you will throw away silly marks because you're not going to be paying attention for the next 10 minutes. So pay attention. This is what every physics science graph has to have. These are the rules for graphing data. First of all, you have to draw and label the x and the y axes. In other words, you're going to put, if you're measuring on the y-axis, distance, comma, d in meters. I want the name of what you're measuring and the units. Symbol is optional, but most of the time you'll put the symbol because you don't feel like having to write out the word in your conclusions like crazy. It's much nicer to use the symbol. We're lazy. Time, t in seconds. Momentum, p in kilogram meters per second. Yes, the symbol for momentum is p, not m, because m is mass, and we ran out of letters. So you'll notice I didn't put any units on these axes. This is not a science graph. Then I wrote time is always on the x-axis. Of course, on Tuesday, one of the activities that we're going to do, we're going to end up putting time on the y-axis. So time is almost always on the x-axis, except for the one graph at the beginning of the year. Go figure. Then you need to select an appropriate scale. You want to have the graph fit as much of the page as possible. If I give you this much graph paper and your graph is that big, I'm taking marks off. Graph should be about that big. You picked a lousy scale. Is that a question, Greg, or are you just scratching your head with the ruler? Okay, be careful, you might hurt yourself. You don't have to have the same scale. On one axis, you might go up by 2s. On the other axis, you might go up by 5s. You won't always be going up by 1. If your graph goes from 0 to 100, Enzo, you do not want to be counting 100 squares. You'll probably go up by 5s or by 10s. Pick an intelligent scale, and we'll do an example of that. You need to give the graph a title. Doesn't have to be anything fancy. Simplest title of all, whatever's on the y-axis versus whatever's on the x-axis. Velocity versus time. Momentum versus force. Whatever. You can get fancier than that, Kelly, if you want to, but keep it simple. Okay. Next page. You'll have to physically turn the page now, because you're following along so closely. Thank you, Aaron. Figured out where we are? We're in the handout, the notes.
Oh, wrong.
No, he's good before. Go. There you go. Plot the points. Okay. Now, I added a sentence here. Nick, I wrote, if we have a measurement with some amount of error, Normally what you do is you draw what are called error bars or error circles around the point to incorporate the error. The equipment we'll be using mostly this year is so lousy, our arrow bars would make a point this big into this big, so we're going to ignore that. I've included it. We're not going to worry about error bars. Often we're going to be way off. Sometimes it'll be close, but sorry, I'm not a multi-million-dollar lab. If your data points seem as though they are in a line, draw the best straight line that averages the data. You're not going to connect them in a jagged line like that. What you're going to do is you're going to draw a straight line that goes through as many of the points as you can and then splits the difference. The rest of the point, half the points will be above your line, half the points will be below your line. You have to use a ruler, no freehand. Okay? Then you're going to determine the slope of your best fit line. Pick 2 points, preferably far apart. Preferably far apart from each other. Don't pick 2 points that are close together because, Matt, if they're only this far from each other, if you wiggle the ruler a little bit, that'll make a huge difference. If they're this far from each other and you wiggle the ruler a tiny bit, you'll still probably be okay. Find delta y, the rise, and delta x, the run, and calculate the slope, rise over run. Note, you need to show these calculations somewhere either on your graph, if there's room, or right beside your graph. I need to see them somewhere. If you just give me the slope later on and you don't show me how you found it, as far as I'm concerned, your pencil just threw up on the page. I don't know what it is. Use the appropriate units for slope. We'll talk about that. Greg, what's the last thing I wrote here? Keep what?
Keep in mind sig figs.
Yeah, we're not going to worry about that part. I'm going to teach sig figs, and I'm going to use sig figs. I'm not going to enforce sig figs. Then you're going to find the equation of your line. You're going to use y equals mx plus b, but you'll rarely use the letter y and the letter x. You'll use whatever letter you put on the y-axis, d or t or m, or and for x, you'll use whatever letter you put on the x-axis, t or v or energy or whatever. Okay? Nerd comic. Yes, I have lots of nerd comics. Guy and a girl are talking. The guy says to the girl, I think we should give it another shot. The girl says we should break up and I can prove it. And she shows him a graph of their relationship, and you'll notice it has a negative slope. The guy says, maybe you're right. She says, I knew data would convince you. And he says, no, I just think I can do better than someone who doesn't label her axes. So not only will not labeling your axes take marks off, it could damage your relationship. Take note. Let's do one together. Okay? They did put a title on the graph at least. That's a start, but no scale, no labeling. You'll lose marks. So here's a graph. Here's some data. Okay? I made these numbers up, but they're roughly accurate. What's the first column measuring? What do you think the letter T stands for? Time. What's the second column measuring? What do you think? M? Velocity. Okay. Which one's going to go on the x-axis? Unless you're told different, and you will be on Tuesday, but unless you're told different, time. So I'm going to write down here time, comma, t, in brackets, seconds. I've labeled that axis with the unit. I'm going to label the y-axis as well. Now, I can go a little funky here. I can flip my screen. You can just spin your paper. Velocity, comma, v, bracket, meters per second. I can flip the screen, which is way cool. Oh, wrong button. I want to go like this. Then like this. Then cancel. Okay, we've labeled our axes. What was the next thing? Scale. Let's do the y-axis first. What's the smallest y value they gave me in the y column there? 5.4. I'll start at 0. What's the biggest y value that they gave me? 15? Now, very quickly, on this piece of graph paper, count how many squares there are.
Twenty.
24? I think I'm going to have to go up, if I want to get 15 in, and I got 24 squares vertically, I think I got to go up by ones. If there had been 30 squares, I might have chosen to go up by twos. That would be a good scale, and that would use up more of the graph. Okay. I'm going to use for my x and y axis the very edge of the graph paper. If you have a whole piece of graph paper with the whole page covered in graphs, you'll actually have to use your ruler to draw an x and a y axis. But I'm going to call this line right here my y axis. What did I say we're going up by? Ones, except don't write this down. Don't write this down. I don't want to go 1, 2, 3. I don't want to. That's going to be crowded and yucky to read. I'm going to go up by ones, but I'm going to label every other one. In other words, I'm going to go 2, 4, 6, 8, 10. Do this, please. 12. 14, 16, 18, 20. I'll quit there. That's a good scale on the y-axis, going up by ones. Jacob, what's the biggest x value they gave me in the column there? 10. And how many squares along do I have the bottom? Is it also 24? Is it? So I got 24 squares. I got to get as high as 10. Would be a good scale if I want to use as much graph paper as possible. Yeah, you know what? I'm going to go like this. 1, 2, 3, 4. Every other square is going to be worth 1. 6, 7, 8, 9, 10, 11, 12. I've forgotten to do something, by the way. I probably should have done this first thing because it was the first thing that I mentioned in my stuff a graph has to have. What have I forgotten to do? Title. Title. How about, what are we measuring on the y-axis? What are we measuring on the x-axis? How about velocity? Velocity versus time.
Will VS suffice?
Will VS suffice?
Yeah.
Yes. In fact, you can actually just put a V, and that's also considered an acceptable abbreviation. You could have a title, Graph of the Velocity of a Car as it Goes Down a Hill versus Time. I won't take marks off for that either. Yeah, I'll keep it simple. If I was doing a research paper, yeah, I'd probably want the title to be fairly descriptive. Are we doing a research paper? No. Are we going to be peer reviewed? No. Are we going to be trying to get published? No. Whatever. Now what? Graph the points. So the very first point says, after 2 seconds, we are 5.4 meters per second. I've got to eyeball the 5.4. 2 seconds is over here. 5.4, halfway between 5 and 6, but slightly closer to the 5. About there-ish. The next point is 4 seconds, 7.8 meters per second. So after 4 seconds, 7.8, just below 8, about there-ish. Six and 10.2, so 6 over, and then slightly above 10, about there-ish. 8 and 12.6. So 8 and then halfway to 13, but a little closer to 13 than to the 12. Kind of about there. The last one I can do, it's on a nice lattice point, 10, 15. 10, 15, I think right there. Race, is there a pattern? Do these seem to form a straight line? Yeah. One of the graphs you're going to do on Tuesday won't. It's going to be a curve. I'll tell you that ahead of time, but you'll notice when you're graphing it, this isn't a straight line. That, you would not use slope-intercept form to find the equation. once you've done a bunch of these, you start to recognize certain equations and you make a best guess. I'll talk about how that one works when we get there. Meanwhile, what you're going to do is you're going to lay your ruler down, go through as many points as you can, and try and have the same number above and below. I don't think this graph goes through 0, 0. Just looking at this, I'm pretty sure it's not going to go through 0, 0. I'm not going to try. When I lay mine down, I get kind of like this. Ish. I think I did pretty good there. I managed to go through almost all of them dead through the center, although this point here is a tiny bit high, but this point here is a tiny bit low. I think I split the difference pretty good. Okay. So there's our graph. Now let's analyze it. What is the y-intercept? Now mine looks to me to be about 3. Yours might be 3.2. Yours might be 2.8. I'll take a fair range. I'll look at your graph because it really depends on how you hold the ruler. There is a way for all of us to get exactly the same answer. It's called least squares linear regression analysis, and it's what they do in real research. You run this through an algorithm, but you also need about 100 points to make it really mathematically valid. We're not going to do that. We're just going to eyeball our line of best fit. So whatever your y-intercept is, I'm going to write mine down, 3. You write down whatever yours is. What does it mean? What's the y-intercept telling me? The fact that this graph doesn't go through 0, 0, the fact that this graph starts off at 3, what does that tell me? At time 0, we were already moving. We have a fancy word for that. You may have used it last year. What does it mean? It's the initial velocity. This year we'll call that VI. Apparently, when we started the stopwatch, this car was not standing still. Now, if you knew it was standing still, if the data told you that, you would try and make this line go through 0, 0, because you know that's a point. B says, what are the units of the slope? We actually haven't found the slope yet. I need to find the slope. Put your pencils down for a second. For me to find the slope, what I want to do is I want to find 2 points that are fairly far apart and that are exactly where 2 grids cross. The fancy word for that, Nick, is lattice points. In other words, I notice this one here is good, and I think I'm going to use this one right here. I would not use, for example, this point and that point, because those don't go exactly through a grid. Now, you are going to have different points from me. Again, I'll take a fair range of answers. So for me, when I find the slope, let me get rid of these last two green ones. I'm going to go slope equals, and I'm going to go rise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over, and I'm going to go run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and I'm wrong. Does anybody see why I'm wrong? And I'll give you a hint. It's the 17. Why is it not actually 17? I counted squares. Is each square worth 1 on our x-axis?
Worth 8 points.
It's not 17. So be very careful you take your scale into account. Vertically, Kelly, I went up by 1s. No problem, count. Horizontally, and I guarantee on your quest, I'm going to give you a graph where at least one of the scales, you can't go up by 1s. So mine is not 10 over 17. Mine is 10 over 8.5. Can you find the slope of your graph? Pick 2 points that are far apart. Do this for yourself. Your numbers will probably be different from mine. And in physics, we don't leave the slope as a fraction. In physics, we tend to make the slope a decimal. I get 1.17. Actually, 1.18. 1.18, Mr. Dewick. You should get a slope close to about 1.2. 1.1, sure. 1.3, sure. 1.9, 9. No. 0.3, no. I'll take a range, but I'm expecting you, Brad, to be reasonably accurate. You're using a ruler, for Pete's sakes. What'd you get for your slope? 2.5? I don't... 1.25. That I'd take. Yeah, 2.5, no. What'd you get for your slope?
1.4.
What's your y-intercept? I think you slid your ruler around and weren't careful. I'd take it, but I'd probably put a little frowny face and say, hey, be more accurate. Okay. So you have, all of you have some kind of a slope around 1.2-ish. If you did not, call me after this is done and I'll come look at it. So the question said, find the slope. The slope is, mine is going to be I'll go to 1.2. But I also asked in part B, what are the units of the slope? Let's go back to where I've showed my work for the slope. There's an easy way to figure out the units, Nick. What are the units on the y-axis? What did we write?
Velocity.
No, what are the units, not what we called it? Meters per second. And slope is rise over run. That means the units are going to be the y units over the x units. It's going to be meters per second per second. Meters per second, there's your y units, over seconds. Now, you did not last year write meters per second per second. Does anybody remember how you wrote meters per second last year? Doug? What? Meters per second squared. And that tells you something. For a candy, who remembers what meters per second squared was a measure of?
It just disappeared from the tip of my brain. I actually just had it.
Okay, next.
Acceleration.
Acceleration. We'll call it raising your hand and allowing me to acknowledge you for a candy instead of blurting it out and guaranteeing that the person is going to get it right even if they didn't know and there's no possible way you can get a candy. I'm just thinking out loud. During this year and next year, those who take Physics 12, often on a test or a quiz, I'm going to give you a graph and I'm going to say, tell me what the slope means. You can memorize every graph out there. That's dumb. What I'll say is, if they want me to tell them what the slope means, I'll divide the y units by the x units, and often, just by looking at the units, I can figure out what we're talking about. Meters per second squared, that's acceleration. Kilograms meters per second squared, eventually you'll all say, that's newtons, it's force. Newton meters, eventually you'll say, that's work and energy, Mr. Dewick. It's a great trick. I will emphasize, Nick, this year, it's worth memorizing the units of stuff, but it's not worth memorizing all the different graphs, because there's like 80 of them. Instead, I'll show you how you can figure it out by thinking for a little bit. Okay? So that's what you'll be doing a bit of on Tuesday. On Tuesday, you're going to be doing two activities. The first is this one here called Assignment 1. And then the second one is going to be involving a pendulum. This first one should give you a nice straight line. The second one that we'll be doing involving a pendulum, I'm almost certain will give you a curve. All right? We are going to pause here. What's your homework? I said I'd give you about 10 or 15 minutes. You got 15 minutes. You can work on the 3 sheets that I gave you. If you finish them in class, hand them in. If not, you got some homework.